Hello Internet, welcome back to Daily Codes. Today we are going to do some bit of machine learning, and the data that we are going to use is the data that we used in the previous video. The previous video was about data cleaning, and we cleaned loan data. If you've not seen that video, you can find it in the description. In this video, we are going to basically quickly prototype a machine learning model that can be used to predict whether someone is likely to default the vehicle loan or not. And the data that I'm going to use is the data that we cleaned in the previous video. If you've not seen that video, you may find it in the description. You can go check it out and learn how we cleaned, or look at how I do my data cleaning more so for that specific data set. Yeah, so without further ado, we are going to build a machine learning model in this video, and that is the scope of this video. Then the future videos will be deploying the model and maybe pushing the model to production. But for this video, we're going to build a machine learning model. Let's just get started. So I'm going to launch Jupyter Lab. I remember this is where we stopped. Jupyter Lab. It's going to launch somewhere here. And we can see the notebooks that we created not yesterday. It's like 4 days ago. We can see the notebook that we created in the previous video and how we cleaned that data. So we have this notebook for data cleaning and this notebook for the code blocks that we saw could be useful maybe when we are pushing data to pushing model to production, or when we are just cleaning and we see that we're going to reuse the code, then we just made a function from the blocks of code. So today we are going to create a new notebook. Then I'm going to save and give it the name ML Lab. Also, all code is in the GitHub repository. You can find the link to the code in the description below. Yeah, let me just confirm here that the clean data is here. It's 11 days ago, not even 4 days ago. Yeah, yeah. So let's import that data. So we'll need pandas. So we're going to use pandas here, import pandas. Then we're going to read that data using pandas. So our data is pd.read CSV, and the path to the data is data slash clean data, I think. Yep. I'm just going to confirm that it's clear on your screen. I think I need to make it bigger. Yeah, as I'm confirming that this is clear on your screen, you can be subscribing if you have not. We do data engineering and data science projects here. If you're interested in any of those, then you should subscribe and maybe click on the bell button so that you can be informed when I upload. But I do mostly slow videos, slow coding. Not so much edited, not so much fancy stuff. But maybe in the future we'll have some fancy things with my videos, but now I just don't have a lot of time to do videos. Yeah, so this is our clean data. And now we can continue working on it to make sure that we have our our machine learning model. The first thing that I want to do, because the first thing you have to do is to ensure that you have good features or features that will help you to predict your output variable. So mostly the first thing you'll be doing is to do feature selection. So I'm going to put here feature selection. So we are going to do feature selection, but feature selection is not just a universal thing that you're going to do, because there are different types of features that you may be working with. The first one will be numbers or numerical features or continuous variable, and then others are discrete variables or categorical features. So you need different mathematical or statistical ways of comparing your features with the output variables, and for different types of input variables. So the input variables are these x variables, and then the output variable is the lone default, in case I confuse you. So let's look at the data types for these features. And it is from these data types that we can be able to determine which. So like here we have this burst amount is float. So we expect this to be a numerical variable or a continuous variable, and then these integers, based on the way we clean the data. Again, you'll find a link to the way we clean the data in the description. These integer are they are categorical variables, and also the boolean ones are the categorical variables. So I'm going to write just to classify them into numerical columns and then the categorical columns, and I put them in a list. So numerical columns will be, so we have the first one is disbursed amount. Yeah, I know if I'm to do this, it will bore you, so I'm going to pause this, and then when I'm done, I'll come back and show you. So, sorry, I should not shout. So I have completed this, and we have these columns are the ones which I consider continuous variables, and we have them, their length is 11. So I have 11 features that are just kind of regression type problem. The input variables are continuous. Then I have gotten the data. So like the X numerical is just the data that is having only the numerical copy this, paste it here. It has only the numerical variables. Also primary number of accounts is numerical because there are so many categories in it. So I left it as numerical. Yeah, so and then the Y or the output variable is the lone default. And now we need the categorical columns because we've made the numerical columns. So let's go down here. The free columns are columns that I could not categorize as categorical columns or numerical columns. So like the date, the lone default, because this is the output variable, that's why I put it here. And then the unique ID, I cannot categorize it as unique column. So we need the data for categorical columns. So I'll call it xcat, and it should be data dot drop. So we're going to drop all the other columns that we have defined above. which is numerical columns, and the free columns, not frozen, free. Free calls. It didn't run this. Then I want to drop that axis. So the axis will say that I only drop the columns, not the rows. So when we look at this, it is only the input variables that are categorical. You may see this as a big number, but it is also just suppliers. Yeah, so this is categorical variables, and we can now get the categorical columns in a list. So I'm going to say my categorical columns will be equal to the list, because I want it as a list. And the reason why I want it as a list is so that when I'm comparing columns, I think in the future, let me just have it as a list so that in the future, when I'm comparing columns, I can just look through this list. So this dot columns, and you can see how many they are. So we have 20 categorical columns. So you're seeing that they're not so many. We could work with all of them, but you may find that some of them are not useful. So it's good to like test and see what is important so that you don't introduce noise when you are training your model. So what we're going to do now is to try to check as we are doing our feature selection. We are going to, I think we should just, this is the problem of recording video without planning. So now before we begin model training, because we're going to at the same time training model and doing feature selection, we in the process of model training we are going to be checking if to check if the data is balanced or it is not. And if it is balanced, then we don't need to. In fact, I'm going to write something here before we train, before we do feature selection. I am going to check for imbalanced data. So with the imbalanced data, I want to check if this data is imbalanced. And the way I'm going to do that is data frame is going to be data. Then I need the column for loan default. Here, where is it? Loan default. Then the column for unique ID. I just want to like have a statistic that tells me whether the data is imbalanced. Group by. We're going to group it by loan default. Then we're going to count. Then we're going to reset index. So when you look at the data frame, forgot a comma, so let's check data where we want only this. dot group by this dot count. Yeah, so we can see that there's so many people who did not default, and then there are few. I think we can have a better visual for this. Let's use Plotly Express. So I'm going to import plotly.express as px. Then we're going to plot this somewhere here. So our figure is px.bar. Then the data frame we've just created. X is this. Y is this unique ID. Then we show fig dot. Yeah, so at least with this visual, you can clearly see that the data is highly imbalanced. And my expectation was this to be even smaller, because if this is your whole customer portfolio and people who default your loans are close to 30% of your data, then I mean 30% of those who don't default, or they got towards, I think, a third of this, it shows that you are making big losses. And I think that's why they shared the data in Kaggle. Also, the data that I'm working with is clean, and it is pushed in the repository that I pushed the previous time. You will still find it in my GitHub repository. The link is also in the description, so you can import it and we work together. Okay, so this is the imbalanced problem that I was talking about. Before we train, we shall be trying to solve this using some methods. And also we are going to be doing feature selection. So there are two things that we're going to be doing. I mean three: feature selection, solving the imbalanced problem, and then we're going to split the data into training and testing sets. So let me put here a comment and let's say model training. And now in the model training, the first thing that I always want to do, because I know I'm going to be training several models, is to define a function that will be used to to to, to like evaluate my models. And this function at least will have like the scores or the matrices that I care about. And I'm not going to define it here because I don't see me using that function after this. So I'll just define the function here. So I'm going to call this one calculate matrices. And it should be taking whatever we predicted as y, and then whatever we had as test, then return, and it should return for me a list of, I am interested in accuracy score. So we are going to import accuracy score from sklearn that I think, is it from model selection? Yeah, from sklearn dot model selection. We are going to import accuracy score accuracy score. I hope this is how it is written. and F1 score. What is it saying? Sklan. So they don't have accuracy score. What's the spelling for accuracy? Oh, it's not model selection. I think it is matrix. Yep. So we have accuracy score and F1 score. So we're going to compute the accuracy score here and the F1 score here. So we're going to do this accuracy score, and it should be, these are the parameters that we pass here. Then the F1 score, and we're passing the same parameters. Then it return for us a value as an accuracy score and a value as F1 score. Those are the ones that I care about for this problem of loan detection. Yep, so we are going to train several models. I'm going to have them in a list, and those models I will attach to them the accuracy score and the F1 score. I'm also going to attach the number of the top categorical features and the top numerical features. And if I used an algorithm for solving the imbalance problem, I will also put the algorithm next to it. So it's a lot of things that are going to happen at the same time. So we're going to write a very huge function, I think, or a small function, we'll never know. So the first thing is to have that list. So I'm going to call it model performances. Model performances is just an empty list. Then I'm going to define model training. But before I define my model training, I think you've heard me talking about the number of numerical features and the number of categorical features that I'll be using for training. Those number of categorical features and number of numerical features will be for feature selection. So I'm going to import modules that will help me for feature selection, and they're just statistical modules. And there are two modules. One, I will use one, chi-square, for doing feature selection for input variables that are categorical, and then the non-categorical input variables I'm going to use another module. So sklearn, hopefully we'll not need to use them, but I think we're going to use them. Dot feature selection. We're going to import. So the first thing we're going to do is select k-best. Select k-best. So select k-best is a module that helps you to select the top k-best features, where k can be a number. Like if you have 5 features which are comparing to an output variable, and you want to get 2 top features that can that are well related to the output variable, or can easily predict the output variable better than the other features, then it will pick for you the first 2. So k, this module helps you to pick for you the first k best modules, but it has to be, you have to pass an algorithm or a statistical function that will help you to do that to it. So we are going to import f class if and chi-square that will help us. So chi-square is for categorical variables, and then f class if is for numerical variables. So I'll use this too. There are several ways you can use to do feature selection. You can read about it. But this I think helps me sometimes. Sometimes they don't help me. We shall see if they will help in this problem. Yeah, I also talked about solving the imbalanced problem. So let me also import modules for it. So we're going to have oversampling and undersampling. So I'm going to say from learn, you need to install this using pip dot oversampling. We're going to import smote. So smote is an algorithm that will help you to, if you have, let's see here, we have few few occurrences of this class here, and we have very many occurrences here. What will happen is that smote will do a regression between all the features and this, and then it will try to sample again data from the regression lines that it has created, and then it will fill this here, and we will have now equal numbers of the true category and the false category observations. So that is what smote does. It oversamples, it increases the quantity of your data. And then we're going to do also undersampling. Learn dot undersampling import. And we're going to import random undersampler. So random undersampler, what it will do, instead of creating virtual lines and then sampling from it and then filling the data, it's going to check the number here and say, okay, this is 28,000. I'm going to randomly select 28,000 features here. So it will reduce this to 28,000 and they will be equal. And there would also the imbalanced problem. So we need that module. So I think now we are ready to write our function that will be used to train all those machine learning models. So I will call this function model training. And model training, we are going to pass in the number of top features for numerical variables, and then the number of top features for categorical variables, and then the algorithm for randomly sampling. So either smote or random undersampler. So the first thing we're going to do here in this function is feature selection. And we are going to use chi-square for feature selection of numeric input, and then categorical output. So we already, for this problem, we have categorical outputs. So we just need numerical input, and we see how I don't know why my brain froze. And we get the first K features from the data. So we're going to have, I'm going to say, so the features numeric is going to be select K best, and the score function is going to be F classif, and the number of columns that I want should be K numeric. So what I'm doing here, I want to get, I'm just instantiating the model. So this is a feature selection, FS. feature selection for numerical variables. The function that we're using for numerical variables is the fclassif, and fclassif means ANOVA. It uses analysis of variance here. In fact, I should just put a comment here so that you know that fclassif is ANOVA. Just know that this is ANOVA. Analysis of variance. So we just define an object here that will use analysis of variance to compute the relationship between your numerical columns and then the output variable, and from there we can get the top k, and then the top k here is the k num that will pass. Then we are going to use this object to get the data that we want. So we're going to say x numerical selected. So this will get the data that we have selected numerically. So all the columns, the first k columns, k numeric columns. So we're going to use this to select them. So we're going to do fit transform. So this dot fit transform, and we're going to transform the x numeric and we're going to compare with y. So this, we are sure that it will pick for us the first k best features for numerical variables based on the output variable, which is y, and it will put for us that data here. The difference is that here you're passing a pandas data frame, but what will be outputted will be a NumPy array. Then the next thing we're going to do is the same for categorical variables. So feature selection for categorical variables will be select k best, and the score function now is not ANOVA, we're going to use chi-square, and the k will be k-cut. Then we get the data. So x categorical selected will be equal to fs categorical, then we fit transform, and we are fitting transforming the x categorical with y. So it will bring for us the top k-cut best features there. So after having this, we are now going to split the data into training and testing, but we'll first need to combine these two arrays. So our training data selected. Let me remove that. So training data selected will be, so we need to concatenate these two categorical features and numerical features. So I'm going to do np. We don't have numpy. We're going to import numpy, I think. Let me import it somewhere up. It's fine. Import numpy as np. Then we're going to do np dot concatenate, and we are going to concatenate this with that. So you can concatenate so that they become like you can add stack rows on top of each other, and that is not helpful because that is not what we are looking for. What we want is to stack columns next to each other. So what we're going to do is to say axis equals to 1 so that we have columns next to each other. I think we can confirm this by having, if I have A as my numpy array np dot array, and this array has 1 comma 2, this is 1 1 2 2, and then I have b being equal to kind of the same thing, but 3 3 4 4. So if I do np dot concatenate, I want to concatenate a comma b, field elements must be 2 or 3 tuples. I got what did I do wrong? Let me see. Axis equals to 0. Oh, okay. So this and let me see if it will do the same for that. Yeah, this. Yeah, so if you see this is numpy array 2D, you'll see if you concatenate at axis equals to 0, you have one array, but the rows are stuck on top of each other. But that is not what we want here. What we want is these ones to be next to each other like columns. So when you do axis equals to 1, yep, this is what we're looking for. And now that is our training data selected. We can now split it into training and testing set. So this is split data into training and testing set. So let's split it here. Did I import train test split? No, I didn't. So let's import it. So from sklearn dot is it model selection now? I think, yeah. Model selection, import train test split. Run that. Come here. Where are we? We don't need this. And down here we're going to say x train x test y train y test will be equal to train test split, and we're going to use that train data selected, and we want it to split y, and we want to be able to reproduce our results. So I'm going to have a random state of a certain prime number, maybe 7. I also want random states for each of these. I think this is okay. This is okay. Yeah, I think that is just fine. I like using random states so that I can be able to reproduce my results. Yep, so here we have RS, which is our random sampler. The reason why I'm doing random sampling after splitting the data, I've seen some people doing random sampling before, is because random sampling can leak the training data into the testing data, and you will not have proper result that can work in the future for your models. So it's better you first split it between train and test, then you can use the training to do your random sampling. But I'm thinking in terms of I may do random sampling or I may not do random sampling. In fact, I should first work on the random sampling bit before I complete this function. Yeah, so let me just put it here, and then I'm going to say random underscore sampler is going to be a hash map, and random undersampler is going to be random undersampler with the random state of 1. Then the second one is smote. I will use SM, and it's going to be smote also with the random state of 1. Then I will just call this one RS, random state, which is just false if we don't want to use any algorithm for randomly sampling our data to solve the imbalanced problem. Yeah, so these keys that you see here, SM, RUS, and RS, are the ones that will be passed here as the value of RS. So I want to see if I'm going to put here a condition that if random sampler RS, if it is not false, obviously, if it is false, then this will not run. But if any of this, then we are going to do the random undersampling. So we're going to have X train result and Y train result. Will be equal to the random sampler RS, any of those dot fit resample, and then what we are resampling is X train and Y train, so that the problem of imbalanced data is only solved for the training data and nothing leaks into the test set. Else we are going to say RS equals to np dot none. You'll see why I did that. Then these will not change. They will just be these values. And we are done with the undersampling and oversampling in case we pass any of those parameters here. So the next thing what we're going to do is to train our models, and I'm going to select, I think, 3 models. This is where AutoML comes in handy, because you can use PyCarrot, or there is another one called, I don't know, lazy something. I think I'll do a video in the future about AutoML. This is where they come in handy because it installs everything for you, and you can easily, quickly prototype your models and see which one performs best very fast by running training only once. But for this video, we're just going to select some few models and then work with them. I think we're going to work with logistic regression, because why not? It's always the first model people run to. So we're going to work with logistic regression. And it is an easier model for people who are moving from statistics into data science. And then we're going to do random forest, because I like bugging and boosting algorithms. And we're also going to use gradient boosting. I'm trying to limit myself into sklearn models that are in sklearn, but you can use any other model. This is just for quick prototyping. Boosting machine. Yeah, so we need to import these models here. So from the first one is logistic regression. So we're going to have it from linear models here. sklearn dot linear model, import logistic regression. Then the second one is random forest. So from sklearn dot ensemble, we're going to import random forest classifier, because we are going to classify, and we're also going to use gradient boost. So gradient boost classifier. I think I wanted to use his gradient boost. No, let's just use these three. Import, then run them here. So logistic regression. We are going to do LR equals to logistic regression, and yeah, I think I'm going to bore you with this stuff. There are so many. I'm going to pause and then I come back and explain what happened. So something has happened, and what has happened is I have logistic regression here defined with the maximum iteration of 10,000, which I think it will never reach. Then it fits this data set for training. Then after fitting it, we calculate for the matrices using the X-test. So we predict logistic regression to predict that. It gives us the Y predict and then the Y test. Then we calculate that. It returns for us this that we created here. And then after that, we add this into the model performances. The same I've done for random forest classifier and gradient boost. So I run that. We have our function created, and now we can now run several models, and then we see what will happen. So this is going to be yeah, we need to like generate the numbers for this, and that. So I'm going to write a weird loop here. So for I don't know how I should do this. How should I do it? Let me just call this call. I'm going to make it a list. Num arrays. And what do I want? I want to have knum here, then kcall kcut here, and arrays here. Yeah, so I'm going to write 3 for loops in the list comprehension that will generate from the outer one. So for k num in range to the length of the number of numerical columns, which is num calls. The same will happen for k cut in range to the length of categorical columns. Then rs, so for rs in random sampler dot keys, and then I run this. So what has happened here? We have generated so many instances. Like I want 2 numerical columns, 2 categorical columns, and then I want you to use random undersampler. The same here, 2, and then I want you to use smote, like that. So we have so many combinations of what would come out in terms of the parameters for our function for model training. There's so many numerical k-cut and so all of them are inside here. And now we can train our model. I didn't want to write 3 for loops when I'm training. That's why I have all of them in this. So that, got that, and then now we're going to say for this in this, we are going to do the model training. Yep. So when we do the model training, all the data will come into model performances, and we shall see the performances, and then we'll do the analysis, and then pick the best model, and then do hyperparameter tuning, and then after doing the hyperparameter tuning, we save our best model. So I like using tqdm to show me the progress. So I'm going to import tqdm dot notebook, I think tqdm dot notebook import. I've written import twice. Import tqdm. So this is from, what did I press? Insert tqdm. Run that, and so let's run this from here. I'm going to put here for this in tqdm. So tqdm is just going to show me the progress that of the loop. So when you run this, it starts with this progress. Yep. So this is going to be enough for this video. My daughter has started crying. I told you that I don't have time. I will complete this in case I complete it before I upload the video, and I will push the code to the repo. You'll find the code there, and what's remaining here, because this is going to take long, what is remaining is hyperparameter tuning for the best model that we're going to select there, and then from there we're going to select the best model and then save it. You'll find the code in the link in the description. Next time we are going to use that model that we have selected, and we are going to build an API around it, hopefully, because I'm feeling like I'm now getting bored of this project and I feel like I need a new project. But next time we're going to build an API around the model that we are going to select. Please look at the code in the repo. I think by the time I'm uploading this video, I would have completed hyperparameter tuning and saving the model, and I would have pushed it into the repo. You'll see more about hyperparameter tuning and saving the model. Until next time, take care. Don't forget to subscribe.